So yesterday I was visiting Scilab at CMU, Carnegie Mellon University. They have a really great security research center. And today I am at another great security research center. So today I'm going to talk about measuring attack surfaces of enterprise software systems. How many of you have heard about attack surface measurement? Okay, just one. So the goal of this talk is to increase this number from 1 to 20, around 20, right? So you're here. So we started working on this project because we had some interesting, challenging questions almost 2 years ago. The first question was, how can we quantify a software system's security? And I think it's a difficult question, right? And another related question was, how can we determine that one release of a software system is more secure than an earlier version? How do you know that? So it's difficult, yeah. That's why we decided to work on this. And let me start with a challenge related to these questions. I think first of all we need to accept the fact that application security is difficult to achieve. So because when you talk about security, you can talk about application security, network security, operating system security, virtualization, other things. But in general, application security is difficult to achieve because of following reasons. The first reason is applications are really complex. So have you ever seen an enterprise application solution which has code around 300 million lines? So these kind of applications exist, and imagine also that the customers are buying these applications and also customizing, adding more code, and also deploy different versions with different customizations in their platform, application computing platform. So another reason is applications are complex. Another reason is complex architectural structure. So we are seeing more and more emerging application structures like service-oriented architecture, software as a service, and applications, Web2.0 applications where we have more, let's say, business logic on the client side in compared to the traditional web applications, and also new application platforms like mobile devices, for example. So there we don't have too much complexity, but we have challenging environments where the applications are running. So the second category of reasons is around what's happening in the area of attacks and security. So security boundaries have dissolved actually. If you look at today's applications, the applications are open to the public. You can deploy an application as a web application, and everybody can see this application. Of course, you have to have necessary credentials to work on these applications, but the attackers may also somehow use web to enter these applications, access these applications. So attacks are increasing. Not only attacks, but also attack types are increasing. So an attack, let's say integer overflow or cross-site request forgery, for example, which have not been known 5 years ago, 10 years ago, they are now there. So the applications written 5 years, 10 years ago, so they didn't know that this kind of attacks would happen, and they were not prepared to defend themselves against this kind of attacks. And another interesting thing is that attackers are focusing more on applications. So they love applications. So and of course there are more potential attackers and more sophisticated tools. This means that the attackers don't really need to have a lot of knowledge to conduct, let's say, attacks which might have huge damage potential. So what is the industry doing? Industry has been doing lots of things around code quality. So we are trying to improve the code quality, all right? So what does this mean actually? So I think the best thing what you can do is with today's standards, you can try to integrate. You should actually integrate the security into software development lifecycle, right? So you have requirements phase, you have design phase. Let's say you have implementation, quality validation, and then you deploy the application, the customer environment, for example. So there are lots of things what you can do in each of these phases. I'm not going to talk in detail about these things, but for example, during the requirements phase, of course, you should understand the requirements, the security requirements driven from your company's policies and also some regulations, for example. And in the design phase, you should create some application threat modeling, and you should perform security risk assessment and follow some security design principles, because design is extremely important because implementation will be based on design. And then you should create some security test cases. Actually, you should also look at the abuse cases, right? So you create abuse cases. And during implementation, hopefully you have really good secure programming guidelines, and the programmers or developers are trained in using these guidelines. And then they do programming based on these guidelines, and then you still run some automated security test cases, and which is very important. You perform some security code review, which might be automated, and or a combination of automated code review plus manual code review, because today's automated techniques, static analysis techniques, are not sufficient to find all kind of vulnerabilities. You really need to do a manual code review. So, and then in the quality validation phase, then you do additional things. If there are some security bugs remain, then hopefully they will be found during the quality validation. Again, you do other kind of tests, penetration tests, for example, and then hopefully your software is secure, and then your software is probably certified, saying, this software is secure. It looks secure. And during the production phase, this is very important. If you configure your software in a wrong way, so a lot of things can happen. Most of the, not most of the, but an important portion of the security problems arise, around misconfiguration. Okay, so all of these efforts are trying to reduce the number of design and coding errors, right? So we are trying to find all possible design and coding errors, and we are trying to remove them before we deploy the applications in let's say, customer environments. So the question is now, is code quality improvement enough? So the answer is this graphic, right? So look at the number of vulnerabilities from 2000 to 2007. So you see, the number of vulnerabilities, reported vulnerabilities, has been increasing. So of course, if you do all of these things I explained in the software development lifecycle, your application is probably, let's say, secure enough. Might be secure, secure. But how many of the developers, are really trained in security? In particular, the developers writing web applications. How many of them have secure object-oriented design, knowledge, or secure system design knowledge, etc.? So it looks, code quality improvement, if you do it really in a good way, this is excellent. All of the big software vendors are doing these things. But it looks it is not really enough, right? So what we can say is our code is only perfect by today's standards. But new vulnerabilities are constantly evolving, right? So the fact is, shipping, vulnerability-free software is hard because it is hard to detect and remove known vulnerabilities, and we don't know about future vulnerabilities. And we have to accept the fact that software will ship always with known and future vulnerabilities. So the argument is here, is following. Software vendors need to change their outlook from saying, my code is very good quality, to oh, my code is the best it can be with today's knowledge. It likely still has security defects. Okay. So what should we do? We should try to minimize the risk associated with exploitation of vulnerabilities, in particular exploitation of future vulnerabilities. How do we do this? So we should try to reduce the attack surface. Because if you have a smaller attack surface, you have a less risk associated with future vulnerabilities, right? And we could make the exploitation harder, and we can also lower the damage potential. So the ideal case is, is to have a, great code quality efforts, and also attack surface measure.